Now that we've gone through all the different types of transformations that we can have, we know our outside and inside rules, let's start to apply them. So we're going to start right here. We have this basic function. Now I really like to copy it over here with dashes. That helps me see the transformation a lot better. So now that I've got this over here, now I can come up to here. I want to do f of x plus 2. So I see that that plus 2 is outside the f of x. So this is an outside, which means it's going to be up or down. And we know that outside is always the same. So this addition is a shift or a translation. And since it's the same, we know it will be up 2. So outside addition will be up 2. So what I'm going to do is take all these points and move them all up 2. Notice that moving them up 2 only changed the y value, not the x value. And then we're done. That's it. We moved up 2, we're finished. So let's try another example. We're going to do the same graph. So I'm going to draw it over here in my dashed lines. And this time I want to do negative f of x. Well, that negative is still outside the f of x. So we know it's still up and down, and it's still same. This is multiplying by a negative, so we know this is going to be a reflection up and down. So I'm going to take all these points that I drew over here and reflect them across the x-axis. So reflect that one across, reflect that one across, reflect that one across, reflect that one across. And there's our graph. We're done. Let's try these last two that are outside. So this one is outside, so we know it's up and down same. And we're multiplying, so this is going to be a scaling. So because it's the same, we're timesing by 2. So this is going to be 2 times as tall. Because remember, outside is vertical. So this is 2 times as tall, so this is going to be a vertical stretch. Now, compare that to this one down here. This is still outside the f of x, so it's still going to be up and down and same. Still a scaling because we're multiplying. However, this time we're multiplying by 1/2, so this is going to be 1/2 as tall. So this is a vertical shrink. So let's take our dashed line here. And let's do A first. So we want it to be 2 times as tall. So essentially what that means is we're going to take the distance to the x-axis and times it by 2. So this point is 1 away from the x-axis, so times that by 2, now it's going to be 2 away. This point is 3 away from the x-axis, so times that by 2, now it's going to be 6 away from the x-axis. Same thing here, 3 away is going to be 6 away. This point is 5 away from the x-axis, so times that by 2, and we get 10. So now you can see that all these points are 2 times as tall. They're twice as far away from the x-axis. And that will be the same rules if you have points down here. You take in the negative area. We find the distance from the x-axis times that distance by 2, so that everything is twice as far from the x-axis or twice as tall. Now let's do B. I want all my points to be half as tall. So where this point is 1 away from the x-axis, I times that by 1/2. So now it should be half away. This point is 3 away, so times that by 1/2. That's 1.5. This one's also 3 away, so that's going to be 1.5 away from the x-axis. And then the last one is 5 away. Times that by half, that's going to be 2.5 away. So you can see that all these points are half as tall as the original points. So that's how scalings work on the outside. You've got twice as tall from the axis or half as tall from the axis. In the next video, we're going to come down here and do some examples that are inside. So these next examples will all be moving things side to side or stretching things side to side instead of up and down.